Okay, well this is the third part in this series on how I built my preamp. So we'll talk about some compression. What happened here is I built this preamp and it was sounding pretty good, but when I would use the clean guitar, I kind of like a more modern compressed sound on the clean channel. I know not everybody likes that, and it has its place, but I didn't feel like I felt like the distorted channel sounded, very good, and I just wanted the clean channel to, have the capability of having sort of a compressed sound to it. Otherwise, it could be hard to use in some situations. So, of course, you don't have to use a compressor if you don't like it, but I kind of liked a compressed sound. So this actually is very, very interesting to me. I built some different compressors, or at least they sort of at least pull down the signal. I don't know if it officially can be called a compressor, but this here is a very interesting circuit. Let me see if I can find something to show you. Okay, so let me see here. Audio compressor, schematic. Let's look for some images. Okay, there you can see there's different stuff here. Let's look at this one for a minute. This is an old one. It's got germanium diodes in it. It really compresses stuff to really low signal. This is not like something I'd recommend you build necessarily, but it's sort of, you've got a signal coming in, and there's sort of like a diode detector which rectifies the signal both ways, low and on the top half of the signal and the lower half. And that voltage sets up a current through these diodes, and when the current goes through these diodes, the effective resistance of them goes down, and that forms a voltage divider with this series resistance. I know that's kind of a quick go through on this circuit, but that's how it works anyways. This is like a dynamic resistance of the actual diodes, and so that's kind of neat. Let's kind of, and basically this is the sort of circuit I sort of messed around with until I found something I thought sounded acceptable. And so you can see it kind of resembles it a little bit. Let me sort of make out a little simpler version of this real quick. Okay, well, I've had a long pause there designing something that I could kind of show how this works. Now here's the, let's zoom out here. And here's the whole preamp circuit. Here's the compressor section, and here's something very similar. I'm kind of using it to explain things. So I've changed a few things about this capacitor. I'm sorry, about this compressor. I've changed some capacitors, some resistances, and so forth. And one of the most frustrating things about this circuit is that these do not model well. I mean, I've built so many of these where I would design the circuitry, it would simulate perfectly, and I would go test it, and it would not work right. It just doesn't match. I don't know if the diode models are no good. At one point, I even took my own diodes and measured the effective AC resistance, putting small amounts of current through them, and did all this stuff. This is so hard to model because it just doesn't work right. I mean, it has to be a problem with the way the diodes are not properly modeled at very, very low current. Because the way these work is you send current through here, and it lowers the effective AC resistance that the circuit sees, and it sort of brings this to ground, and this voltage divider starts working. So let me just kind of walk you through that. Circuit comes through here. There's a little bit of resistance. you've got this diode detector here going to ground, and you've got, for the negative cycle, you've got a diode detector going to ground. And that sets up just a kind of like a voltage here and a voltage here. This is a positive voltage, this is negative, and of course current runs down this thing. This remains about at ground depending on the signal, and we'll talk about that in a minute. And it lowers the AC resistance, and then the circuit here, this is a voltage divider the signal's coming through, and it sees no resistance here, or very low resistance, and then that goes down to ground there. So basically this whole voltage divider gets grounded out. So you've got signal coming through, and then you've got a voltage divider cutting things in half basically. And let's just kind of look at this circuit. Now the reason that these values are different here versus down here is because this doesn't model well. This actually works in real life. I mean, I've tested this with oscilloscope and wave generators and everything, so it works fine. But I had to, basically the modeling didn't work in the computer, but we're going to use this modeling because it does work, at least to demonstrate what's going on. So like if you got this signal coming through, I've got it going from I think 0 to 1 volt in steps of 0.1. When you look up here, you can see, let me just kind of look at that. You can see the higher the voltage goes, this just makes sort of like a DC signal. Yeah, there's a little bit of variation, but it's just kind of they call it a diode detector, and it basically rides along the top of the signal. Let's see if we can see that. Yeah, let's zoom in on this, see if it looks okay. See, I don't know if you can really tell, but it's like a wave that's supposed to be riding the crest at the top of the signal there. So you've got sort of, let's zoom out. So I have like a delay set on this, so it just starts, there's a pause, and then the signal comes through, and then you get the positive signal and the negative. That's right here sitting on top, and right down there you can see current goes through there. And then and the current is, you can see it's going through there. There's a combination of feedback, I think, coming through here, because when you look at this current, you've got sort of current coming down here as current's going through there. So there's sort of feedback here, but the point about it is that there's like very little AC resistance through here. Some people will omit this. Some people, I think, you can kind of, if you're very precise about things, you can totally omit this and send like very tiny amounts of current through here. And these things, if they're matched right and they're the same, then they'll have the same effective AC resistance, and you'll get the same sort of effect. Through here, we're relying on this to sort of drop down a lot where there's not much resistance, and then this sort of kicks in. I think you don't have to diode match as well doing it that way. And you may hear that term with diode compressors, diode matching. It's a real pain, and you don't want to do it for simple stuff like this. But so you can see this is sort of how the circuit works. And let's take a look at the input versus output actually. Here's input. And by the way, I don't have any series resistance on this thing. This is just for demonstration purposes. So sorry it's taking a while. So there's the input going up to 1 volt, and here is your output. You can kind of see it coming on like with an attack there, and then the blue is there. And let's just zoom in on that. There you go. You can see it. Now let me do it this way. Let's see if we can get a better view of this. You can see this is 0.1 volt. The signal in and out are about the same. 0.2 volt, about the same. 0.3 volt, about the same. And you get to 0.4 volts, and that's kind of ducking down. By the time you hit the 0.5, you can see this just kind of, once you reach that threshold, this circuit just starts pulling this down. I'm going to multiply by 2 here. Should be about right. Yeah, maybe 1.9. You can see they're sort of course, this is twice as, I'm just comparing input to output signals in terms of shape, just to kind of show you it's not really clipping as much as it's compressing. And that is another thing that is peculiar about this circuit. And this gets a little bit hard to sort out sometimes, is that really this thing will also clip, because if you send a big signal through here, these sort of diodes connect like clipping diodes. Let me see. I've got a circuit here to demonstrate that. Let's pull this down. Okay. Now, okay, so what I've done here, same exact circuit, but I've just disconnected this. So the signal goes through here, but there's going to be no current basically going down from the signal, making a diode detector, fueling the, fueling some current through here. And let's just see the difference here. You can see, I'll give it a minute. Oh, looks like I'm going to have to open that back up. Crash, sorry. Okay, so basically this crashed for some reason. I don't know why. Maybe because of the video or something, but I think we've got everything right here. We've got the same resistors, capacitors. I think we're good to go here. So I'm gonna hit go here. Okay, I'm not gonna touch anything until it runs, because I don't need it crashing again. Okay, so here we go. Here's just some input. It's got the delay on it. So here's the output. You can see the reduced signal. And here is also a reduced signal. How is that happening? We're not feeding any current through. Well, it's basically, it's seeing these as clipping diodes, basically. So let's take a look at that. I'm in fact going to not look at the input, and we'll just look at these two. Now this, you can see that clearly this circuit is reduced in amplitude much more than this one, probably by, I don't know, almost a factor 2 anyways. And you can see the shape of it is a little bit more round. So this is basically kind of starting to clip, and that makes sense, because this is a 0.7, you start to get like a soft clipping when you just use diodes there. They can, when the voltage gets a lot higher, they can be more, the waveform's going to look a lot worse than this. But let's just kind of zoom in on this. Again, this is just kind of the clip signal, and this is the compressed signal. Just going to maybe amplify that to 1. And I'm just trying to compare sort of waveforms, if you will. So we've got these peaking. You can see this is like a little bit wider. It's coming on a little differently. Hopefully you can appreciate one is a little bit fatter and less looking like a sine wave. Just close that. So you may say, well, this is just really clipping or whatever. Let's kind of look at this. This is a different way to look at this same circuit here. So we've got here same circuit, but we're going to feed a signal through here, and we're going to look at a separate signal this way. Now this signal will be on all the time. This one is going to come on a little bit after the start of the simulation and then quit, so you can see the effect of pulsing through this side chain signal. So let's try that. Okay, so it takes a little while to run. Okay, should be done. So what do we have here? Let's look at input first. Let's look at the out. Well, yeah. So what do we have here? Let's just look at the main signal here. Well, there it is. You know, we're sending a side chain through, and it's reducing the level here. But it's also a bit reduced anyways, just because of the circuit and probably a little soft clipping. So this is sort of, I mean, it does, okay, this is before the compressor's on. And here is the let's do it this way. This is the signal, and this is with the compression on. We're going to just multiply this, bring it up a little bit. You kind of see that there's sort of, you know, there's a little bit of soft clipping there too, but there's extra. You can't just explain it by clipping, because, like I said, if you compare the clipping circuit to the compressed circuit, you'll just see that the compressed circuit is indeed compressed more, or at least the peak voltages are lowered. Okay, so here's kind of the effect of some initial soft clipping, and then you've got more, you know, more gain reduction through side chaining in the signal. So why am I talking about all this? Well, you know, this circuit, it is peculiar because really there's two things going on. There's a little bit of soft clipping, and then there's some compression going on. And you might think, well, I'd love to make a threshold control. I'm just going to take the signal and just amplify that up or down, and that'll, you know, sort of vary the threshold at which this comes on. Problem with doing that is you have to sort of turn on the compression by side chaining early enough so that it doesn't clip. So it doesn't really work well to try and, like traditionally, in my experience, it doesn't work well to try and feed through a signal and vary that as a threshold control, because, again, what happens is you almost need to turn this compression on with the side chain before it starts to clip too much, or it just starts to sound bad. So I know that might be a long-winded discussion about this, but you know, at first glance, you might say, well, I'm building a threshold control right here. And, you know, I've tried it. I've done a lot of it. I've built a zillion of these because you almost have to by brute force, unless you have really good modeling, because it does not model well. So how did I come up with these values? And I kind of mentioned the words brute force, and what I mean by that is trial and error on all this stuff. I had a oscilloscope hooked up here, watching the envelope detector. I watched the attacks and decays by sending through signals. I watched the waveforms fall down as I would, you know, turn up the signal and adjust these resistors. And all that time, I also had to listen to stuff, because I built some perfectly, well, I designed some, well, I would say like perfectly designed diode compressors. And I would build them, and they would sound like HE double hockey sticks, because it just wasn't modeled right. And, you know, the guitar is sort of, it's got a signal with these really quick peaks that come down, and you know, it's a very, very dynamic signal. So you almost have to like experiment quite a bit with this, and this ended up, there may be better values for this. I mean, I can't say, basically it was so frustrating to design this. When I finally got something that sounded acceptable to me, I just kept it, and it scoped okay. You know, it scoped okay with the oscilloscope and with sending in different signals, that I just kept it. I'm like, well, this works fine, and there's no reason to, you know, try to make it better at this point. You know, at some point you just have to move on and say, well, this is working for now. I mean, if you make this better, please respond, or, you know, send some comments, because I'd love to see what you come up with. So that's this in a nutshell. Some interesting things about it. I didn't actually mention this, but do you notice anything about this circuit compared to the other ones? And the first, what you may not notice here is this is totally passive. There's not one transistor in here. There's not even a voltage supply, and I think that's kind of neat. Now you can't really build it like this and use it without a buffer on each side. But if you do that, you can. In fact, I don't have a video on it because I'm kind of using it here, but I basically put a buffer here, and then I have one knob there and a threshold control here. Of course, we use different values, and it makes a fine diode compressor for like a guitar. You might find that the bass guitar just has too low of a signal to turn it on. In other words, you got to get past that threshold where the compressor comes on. And I actually have another nice circuit that pre-amplifies the signal, and that's a different one, but I may do a video on it. It's basically a diode compressor, kind of a 3-knob basically, I think, with a, anyways, it's a really, really cool circuit actually, where it's just, works great. I mean, I don't know why diode compressors are, so expensive. I mean, I know they're higher quality than this. This is sort of a consumer level circuit, because really, when you look at these things are turning on, like, they're turning on at like maybe 300 millivolts or something like that when they start to operate, which is perfect for a consumer signal. I mean, consumer level signals or guitar level signals, I think the RMS value is like 345 millivolts if I'm right, and the peak to peak is like 440 or 450, something like that. I mean, with it's that's the range that a lot of these things are built in. Now, if you want a pro audio level, those are much higher audio levels, so you can see where this would get more complicated because you're working with larger signals and you just need more stuff here. I try these with LEDs, by the way, and I'm just going to throw one extra thing in here real quick. It's something I never got to do, but if anybody's out there and they want to just try something out that's cool, I'm going to give you a glimpse at something that I think might be neat. Okay, so at this point, I think I've said all I need to about the guitar compressor. But I did want to, I had this idea, and I think if somebody out there wants to work on this, or, this is an idea. I don't have the time for it now, but it just seems like such a cool idea that it might work, okay? Now, if you look at this, okay, this is the same exact circuit, basically, except for you've got a transistor here, a PNP and an NPN here, right? Because going from base to emitter there, that is just a diode, basically. Of course, you could have this here too. And so the idea is you could probably do something like this. I'm gonna have to sort of move this a little bit just to give some room. But you could probably do something like this with a configuration here where you've got voltage. Sorry, doing this on the fly. Okay, so we've got, I don't know, I'm just going to put something through there for a minute. I have no idea what the values would be really. Let's see here. Oh, that's not what I wanted. What is it? New component. That's it. So you can see, you might see what I'm doing here, but have this at like 9 volts. Maybe have this at -9. This could just be an ordinary transistor. These might be dual gang pots or something like that. The idea here is like whatever current you've got going through here, you should get some gain pickup with it through these transistors. I mean, that's what they are for making gain. So I wonder if you could sort of make a circuit something like this, or maybe even pull these out like this and do something like this. Just cut this resistor out there. There are different configurations you could think about instead of so it's kind of messy, but and maybe instead of having a 100K there, you might have two, 50K or 47K to be realistic. I mean, there's like different ways you could think of doing this, but you might be able to get more control, or you might actually be able to send less current this way and amplify it more. But it does give you maybe maybe you can get a faster attack that way. It's just an idea. I mean, you could see how you could sort of make this a little more active circuit. You could also do things like put a little buffer here before you go down through this branch, thereby, because if you put a big buffer here, you see, you can really, and then maybe a capacitor to ground after the buffer. I think you can flatten out this envelope and make it a lot smoother and more consistent. So there's like a lot of different variations you could use on this, but I don't know. I just thought I'd show you that because I do find it an interesting circuit, but at some point I just got a little too much of this circuit. And if anybody else wants to dive in and say, hey, I'm all in for experimenting, well, that might be a neat project to try. So I don't have anything else for this video. I think the next thing I was going to talk about, these are kind of all features of the preamp I'm building. I'll probably talk, I guess we'll go to the clean channel next. Not sure how much there's to say about that, but we'll talk about it. Anyways, hope this helped you or hope you like it. I know it's not for everyone because some people are at different levels. Everyone is at a different learning level. As far, everybody always is. I mean, my circuits to some people they say are too simple, and I use too simple components. So it's kind of the point I like doing that. But everybody learns, and as they gain more knowledge, they see things a little bit differently. So you may be at a stage where you don't understand what I'm talking about, or maybe you know way more than me, and you're saying your explanation is a little off. Either way, just comment below, and I'm happy with what the preamp sounds like is one reason I'm sharing it, but I always want to learn more. So again, thanks for watching.